I want to welcome everybody to our Career Accelerator lecture series. This is lecture 2 of the spring of 2021, and we are glad you're joining us, and welcome all those of you that are still coming in. We're proud today to have Dr. Vicky Johnson, who is chair of our advisory board for the School of Engineering, and we're excited to have her talk about lifelong learning and the importance of learning. Learning doesn't stop as you go through your career. You're just getting started. Believe it or not, you're just getting started. A few words about how this is going to work for those of you that haven't been with us before. So the way this is going to work is Dr. Johnson's going to give us her presentation as we go. You are encouraged to submit questions through the chat as we go. She may or may not stop and answer those. Most likely we'll save those till the end. And I'll be receiving those throughout the presentation. So as she's going on, you can chat, you can communicate with me, and I'm the only one that's going to see those. And I'll be collating those. We'll probably have some come in that ask basically the same question. And then at the end, I'll ask a series of questions that have come in, and you're welcome to continue to ping new questions in back and forth and stuff as we go. So we're probably typically this runs about an hour or maybe just a few minutes longer. We'd love to have you stay the whole time. If you have to leave, this will be recorded. So it will be available as a Zoom recording. It will also be available on the KU Engineering YouTube channel within a few days. So with that, I'll go ahead and introduce our speaker, Dr. Vicky S. Johnson, chair of the KU School of Engineering Advisory Board, will speak with us about what it's like to work in the government, private nonprofits, academia, and industry. And she'll also talk about the role of lifelong learning in having a successful career and successful life. Dr. Johnson is currently retired and enjoying life in an RV while hiding out from winter in Arizona. In addition to her many volunteer activities, Vicky is practicing in shooting and skeet competitions. Her employers have included NASA Langley Research Center, the Aeronautics and Space Engineering Board at the National Research Council, the University Space Research Association, the National Institute for Aviation Research at Wichita State University, Embry-Riddle Aeronautical University, Boeing, Cessna Aircraft Company, Textron Aviation, and Spirit Aerosystems. And just some of her lifelong learning activities include a Bachelor of Science, Master of Science, Doctor of Philosophy, Master of Business Administration with an emphasis in Management of Technology, a Black Belt, a Master Black Belt, Fellow of Society of Women Engineers, Associate Fellow of American Institute of Aeronautics and Astronautics, and Certified Systems Engineering Professional. So with that, I'm going to go ahead and introduce Dr. Johnson. My video is going to disappear, but I am still here, and please send in your questions. We love the interaction, and we love taking your questions. So with that, Dr. Johnson, take it away.
Thank you, Dr. Parsons. I'm really happy to be here. I decorated the front page of my presentation with my current hobby and lifestyle. I'm really happy to have had a fairly successful career and been able to retire and do some other things. I don't want to give you all the idea that you should do that now. When you've been working in industry and at your jobs, having a career for 42 years, then you can talk about this also. Because this is a good academic exercise, I do have some learning objectives for today. I want you to understand the importance of lifelong learning, be able to identify different ways to accomplish lifelong learning, and appreciate that degrees and certifications are one way that you can demonstrate lifelong learning. I'd also like for you to get a sense of how important it is to participate in professional societies, and finally understand how different types of employers and work are appropriate careers for engineers. We have a lot in here to offer this. In terms of an outline, I'm going to talk first briefly about the difference between a job and a career. I'm going to talk about lifelong learning using my own example as one way. Talk about different types of jobs and how they can contribute to a happy career. And I'll wind up both of those sections with what I missed and what might appeal to you. The first thing, the difference between a job and a career. A job is usually something you have to do. You go in at 8 o'clock, you leave at 4:30, you get your 30 minutes for lunch, you get your 15-minute break in the morning and in the afternoon. You may be paid by the hour. Your objective is to keep going to work every day. You don't think about what's going on at work much when you're at home. A career is the opposite. A career, you're really involved, you're building, you have goals, you have things you want to accomplish, you're able to accomplish those things. You may think about work outside of work, you may work some extra hours, but you're all focused on attaining something beyond just going to work every day. There's a saying that if we're not learning, we're dying. There's no such thing as sitting still. You can't say, I'm done learning, I'll just function now. Because if you're not learning, you're dying. It's very important to keep learning. And one of the goals of engineering education is to give students the appreciation of the need for lifelong learning. There's an organization called ABET, the Accreditation Board of Engineering and Technology. Your faculty members have a love-hate relationship with ABET. It's difficult when they come to visit and check on the quality of what's happening, but it's critical for you because that's one of the things that tells your future employers your degree is very valuable because it has passed ABET requirements. And ABET says engineers need to understand you're not done learning when you get your degree, you're just beginning. A few years ago in a book club at Spirit Aerosystems, we read a book called The Four Tendencies by Gretchen Rubin. And Gretchen broke people down into whether or not you meet other people's expectations of you or external expectations, whether or not you meet your own expectations of yourself, internal expectations. You can see the really perfect person is the upper right-hand corner, the upholder. They meet their requirements of themselves. They meet the requirements other people have of them. And at the bottom left is the rebel who doesn't meet anything. That's the one that's hardest to work with. But if you're a person who can meet your internal expectations, you can say, I am going to learn this. And you can just read a book and be successful. If you're me, I'm an obliger. I love to meet other people's expectations of me. I always show up with my work done, my presentation ready. I cheat myself out of a lot of things. I don't meet a lot of my own internal expectations. For me, the best way to learn is to take classes because it turns my internal expectations into external. I've got a professor, somebody that's expecting me to do assignments, turn things in, learn things. I want you just to be aware of that as you think about how you learn best. But I'm going to make an argument that degrees and certifications are really good ways to have criteria and artifacts that show that you have indeed learned something. When I write my name with all the initials I could use, it looks ridiculous. And I don't use all those initials. Sometimes I use different ones depending on what my message is or who I'm working with. But this does illustrate one learning path. I'm going to take you through that path this afternoon to see what is this all about and why does it matter? And one thing you might be worried about, you're there working on your Bachelor of Science degree, you don't have any initials you can use yet. If that's you, you could use the initials NIAN, which means no initials after name. And I've given you my example there. Seriously, I don't suggest that you do that, but it is something worth thinking about. I would encourage you instead to think about going after some of the other initials that are meaningful. My first initial is something that many of you are working on or you've just achieved recently, and that is a Bachelor of Science. In my case, it was aerospace engineering in 1982. I went to what's now the Missouri University of Science and Technology Back then it was the University of Missouri at Rolla. If you want to be an engineer, this is the entry-level criteria for getting into engineering. In my case, while I was doing that program, I was a cooperative engineering student at NASA Langley Research Center. I was lucky that NASA had just restarted their co-op program with Rolla, and I was able to get into it. A similar activity for you might be an internship, trying to get work in the summertime that's in your field. The way the co-op program works, I alternated college and work semesters. So no summer vacation. After I did 3 semesters, fall, spring, and summer in school, then I alternated work and school until my last year when I did fall and spring together to do the senior capstone design. One of the benefits of that was helping me pay for college and covering my living expenses while I was at work. It also got me some really good work experience. When I graduated, I interviewed with some private industry companies, and I found out that they valued that work experience about like they would a master's degree, which I did not have. The other thing that was valuable about it was when I graduated, I was able to get a job at NASA. The best way to get a job as a new engineer is to have an internship or co-op experience as an undergraduate. The next degree was a Master of Science degree. And I did that and graduated in 1985. My degree was from George Washington University. They actually had a center there at NASA Langley. The classes were in the building I was working in, so it was very convenient. I would take off from work to go to class and would go home and do homework on my own time. There were some other students there who were GWU graduate students. They took 2 classes a semester. I took 1. That was enough. NASA paid the tuition for that. It was a very easy way to get a master's degree. I was very fortunate that NASA did not require making up the work time. That was part of what they paid for. In talking to other employers about what they do, there are many employers offer graduate study. They'll say, we have a university in town that a lot of our employees go to, but we want you to take those classes on your own time and do the homework on your own time. And if it turns out that you need to go to class on Monday morning, we'll let you work late or work a Saturday morning to make up the time. And employers will pay the tuition for that. I am a huge fan of using other people's money for education. It makes life better when you get out and go to work, not having to repay loans. One thing the employer paid tuition is subject potentially to IRS limits that may turn some of it into taxable income or limit how much your employer can pay. I didn't find that to be an issue until I worked on my MBA, and those courses tend to be more expensive. It's really a good activity, and it's almost an expectation for many employers that when you come to work, at some point you will work on a master's degree. It's a really good way for you to work on differentiating yourself from the herd of people who come in with bachelor's degrees. You're going to differentiate by doing a good job and being the first one to volunteer for assignments, but getting a credential also is very, very helpful. The next one is PhD. And this is the one that I got at the University of Kansas. NASA sent me full-time when I got finished with my master's. In fact, I was still finishing up my thesis and getting ready to graduate. I left Langley, moved myself to Lawrence. NASA sent me, they paid my tuition and they paid my full salary. So I had to pay to live, I had to pay to move there and back, and I had to buy my books. But I was a very wealthy graduate student. It was very, very appreciated. I spent 1 year on campus doing the 30 hours of coursework. So that was fall, spring, and summer. And then I returned to NASA to do my research and write my dissertation. and I would travel back to Lawrence to do things like comprehensives and qualifiers and defend my dissertation. And of course, come to graduation, which was a real highlight. Those of you in the Aero program know Dr. Saeed Faroqi, who is now retired, but he was around back then, was one of the guys who came to graduation. It was fun. If you don't happen to be at NASA or a government lab that has good educational opportunities, when you start talking about a PhD, industry may say, well, we think that would be great. Good luck. We hope we'll have this job for you when you get back. In some limited cases, companies will do what NASA did, pay to send someone that they really want to get that skill and they see the potential. They're a high potential employee. But most of the time, it's good luck. It's hard to do a PhD part-time, taking classes at night, trying to do a dissertation. The other option to get a PhD is through the university, being a graduate research assistant or a teaching assistant, and winding up working with a faculty member and doing your research on a topic that they have funding for. In my case, NASA funded my research for my dissertation. I did my work on life cycle cost in conceptual design of subsonic commercial aircraft. And the agreement NASA had with me and with KU was that when I went back to actually do that research, I would get 80% of my time to work on it. So I spent about 2.5 years at work working on that and got finished and was successful. One of the questions you might ask is, why would I want to get a PhD? One reason is so that you could be a professor at a university. It used to be, back when I first started out, universities would hire people from industry as professors of practice to teach the airplane design class or something special they had from industry. But it's gotten to the point where in the university infrastructure, you need a PhD to really thrive there. The other reason you might get a PhD is to do research in government or industry. And those are both really, really good reasons. I do have one caution for you, and that is that there is a danger of winding up with a high salary as a PhD worker and industry doesn't know what to do with you. I have had that experience to a certain extent a little bit, and it made me stop and think, if I were going to do this again, I might have done a Doctor of Engineering rather than a PhD, because the Doctor of Engineering, you take some business classes in addition to technical, and you do a project. And that demonstrates to employers that you could come in and help them get something accomplished, maybe to move some research forward. So you need to think about what your ultimate objectives are. My objective at the time was, I want to work at NASA and in industry, retire early, and then go play with the students. It turned out that's not what I did. It was a good goal though, and I definitely do not regret getting my PhD. The next thing is MBA, Master of Business Administration. In my case, I got that with an emphasis in management of technology. I worked in research in several places, worked at NASA. I was at Cessna at the time. I had been out of school for 20 years, thought it's time to learn something new, and I really would like to do this. I got it through the University of Phoenix, which has a very mixed reputation. It is an online, and they have a program called Netflix where you do most of your classes in you go to a class the first week and the 6th week, and in between it's all online. Some of the classes were actually online. I'm a proponent of that program because they have a wonderful online library. They had a requirement that every paper that we wrote had at least 3 current resources with what to help strengthen the point that we were making in our papers. I asked other people who went to local programs around here, what did you do? We used the course notes in the course books and not the library so much. So that's my take on University of Phoenix. They are expensive, but it was a good experience for me. One of the questions people have is, well, should I get a Master of Science or an MBA? And the answer is, like everything else, it depends. Depends on what your goals are. But if you're going to do technical things, my recommendation is do the technical degrees first, because your skills go away ever so fast. I know that you'll be disappointed to know, but when you're working for NASA or Boeing or whatever company, you're not doing usually a differential equation every day or working on a differential equation. So those things do depart, and you want to use them while you have them. The MS is very valuable in helping you get more in-depth in your technical skills. The MBA helps you integrate the business perspective. And your employer is in business to make money or spend money responsibly. And so it's very important to them that their employees understand and have a grip on the business perspective as they're doing their work. It's useful to everybody. And there's room for both because you've got a nice long career. The next area I moved to is after I got my MBA and I was still at Cessna, I had an opportunity to get into the Textron Black Belt program. I skipped over Green Belt, which is the lower level of Six Sigma work, because my boss said, you already know that stuff. You need the tools. It turns out Green Belt focuses a lot on soft skills, working with people, facilitating meetings. Those are very valuable skills also that you need. So if you have an opportunity to do a Green Belt, that's a good place to start, and you will have fun. You'll learn some new things and have a chance to do a project or some projects that contribute to the company and give you visibility. In my case, that black belt training was 6 weeks of training, 1 week a month. We were training in Rhode Island and in Alpharetta, Georgia, locations that Textron had business units. That training was all company paid, and the work was mostly on company time. Sometimes I would wind up putting in some extra hours to get things done, but it was mostly paid for. There was a competency exam to say, did I learn the materials? And what I found is that was a great way to learn new skills, meet new people in the organization, be able to mentor the green belts. So you get a sense of what are the problems around the company and who are the people that are good at solving those, and then demonstrating your own competence in solving problems. It's a very, very good program, and it's recognized by industry especially as worthwhile to the company. I went ahead after I got done with black belt and got my master black belt again at Textron Aviation. That was a couple of years later. There was some more training. I believe it was 2 weeks worth. The big focus was statistics. Like the black belt, it was company paid, mostly working on company time. There was another competency exam. Basically, there had been one for design for Six Sigma, and I had to take the other one that was the regular Six Sigma exam. And it gave me opportunity to mentor not only green belts, but also black belts, and then to solve even more complex problems for the company. One of the reputations I developed there as a master black belt, Textron, the corporate entity, the CEO made a requirement that all managers within Textron would get their green belt certification. And I wound up with the reputation as somebody who could take a manager who was struggling to get over the finish line and get them there. And it wasn't by doing the work for them, it was prompting them and nagging them to get the work done. But it certainly gave me increased visibility into what was going on all around the company. This next thing is a designation, a an award, I'll say, and that is I'm a member of the American Institute of Aeronautics and Astronautics, have been since I was a freshman in college. In 1998, my colleagues at Embry-Riddle said, it's time for you to be an associate fellow, and they led the work on the nomination package. It's quite an involved thing with a lot to fill out, and then letters of recommendation from your colleagues. But it's a recognition of your accomplishment, and it's a lifetime recognition. And the next step would be AIAA Fellow. AIAA also has honorary fellows. I give you this as my example. The other professional societies for the other disciplines in engineering have very similar kinds of professional societies and recognitions. And those are always good for your colleagues to recognize that you have been set aside as having achieved something extraordinary. This next one was earned. There's an organization called the International Council on Systems Engineering. I actually joined that when they were 3 years old to give a paper on the NASA USRA University Advanced Design program that I was running, talking about statistics and measuring how we were doing on impacting capstone design courses. And then after I got to Wichita and got involved, I went back to NCOSE where I was doing a job more as a systems engineer. The way their certification works, there's a test to demonstrate that you've mastered the material, which is primarily their systems engineering handbook. They have an associate certified systems engineer professional, which is someone who's passed that exam. If you have at least 5 years or more of documented experience in their 13 systems engineering disciplines, then you can apply to be a certified systems engineering professional, which is what I did. That is peer recognition. It's really good. Companies, for some of them, that means a lot, especially if a company's working in the defense world. Defense is requiring systems engineering. Smart companies know that systems engineering really helps. You can't usually get a degree as a bachelor's in systems engineering, but there are master's and doctorate programs, and there are also certificate programs. The CSEP requires that you have experiences and submit a renewal every 3 years, which I did that in 2020 to renew for another 3-year period. They do give you credit for things like running organizations and organizing meetings, delivering presentations on systems engineering. This last one is brand spanking new. The Society of Women Engineers has a rank of fellow. And in that, you're nominated by a SWE member. It takes a package. It takes letters of recommendation. It's a recognition of technical and SWE contributions. And that's another one of those lifetime recognitions. It's nice to get, and it's useful to have to show that, hey, yes, I have been contributing outside of my narrow little job. And the final one I'll mention is another brand new one. This year I got the AIAA 2021 Sustained Service Award. I said, if you get old enough and survive long enough, then you're eligible for things like sustained service awards. In the case of AIAA, I joined as a freshman. I joined in September of 1977. I arrived at Rolla in August. Along the way, during my time there, I served as a section officer. When I graduated, I converted to a professional member. I served on section office positions and committee chairs, worked with other people to do work. When you move around, that's a really great way to meet new people and build an instant network. Plus, you start to see the same people at different places around the country or the world. I was able to serve on the Emerging Technologies Committee and the Systems Engineering Technical Committee along the way, and that counted. I'm currently serving as chair of the Wichita section. This is a recognition for long-time service, and it's a really good thing, whether it's AICHE or ASME, all of the different engineering disciplines have societies, and it's worth looking at. SAE is one that applies to mechanical and aerospace and anybody interested in transportation. So this is a really good thing. So that's the end of my list. The question now is, what's missing? What I didn't do was professional engineer. To do professional engineer, you have to have 4 things. One is an ABET accredited BS degree. There's that importance of ABET again. There's a fundamentals of engineering exam that's really over coursework type things. Then you work under a professional engineer for 4 years and finish up with an experience-based exam. And PEs are required for some fields and companies. If you're going to be a civil engineer, you probably need your PE. If you're going to be a consultant, you'd probably benefit from having your PE. It's not required as much in industry, at least the industry I'm familiar with is aerospace. I haven't really seen it much. I do regret that I didn't do that. And my recommendation is do the fundamentals of engineering exam early. I know I've seen when I'm at Lawrence posters, flyers on the bulletin boards about classes to prepare for that while you're still working on your BS. If you don't do it then, do it immediately after, because like I said earlier, those skills go away, and that's a bad thing. All right, I'm going to switch focus a little and talk for a few minutes about different kinds of jobs. Dr. Parsons read my list of where I've worked. You could interpret that as I can't keep a job. I wound up with sort of my own unique take on what a career looked like and traveled around a lot. I'm going to make a lot of generalizations based on my experience. You all know that it's very bad to generalize because you often trivialize something that really is important, but this is the best I can do. And if we want to have dialogue when I'm finished, that would be good. I'm going to provide my examples, and I'm going to conclude with what I didn't do that might be interesting to you. My first job, as I mentioned, was at NASA Langley Research Center. I would lump that into government labs, and they're really good places to work. I've listed some pros and cons. One thing I found, especially at NASA, is they were really good at coming up with good assignments for inexperienced engineers. It's a great place to learn. I showed up not having had aerodynamics, not having had any computer programming. Back then, computers were not that prevalent. You guys laugh at me now, you know I'm really old. But my first work assignment was to redesign the wing thickness distribution on NASA's supersonic transport configuration to try to minimize wave drag at supersonic speeds while maintaining a structural box with a minimum thickness for structure. That was a great assignment for me, and they were really good at sending me away to scratch my head and think and try, and then give me some more information in time before I got totally frustrated to be able to do that again. Excellent learning opportunity. Really excellent graduate study opportunities. You heard my story about going to graduate school. It's flexible, tends to be pretty laid back until employees abuse flexibility. I remember while I was there, at one point we had to start signing in and out because the IG was looking and finding people reporting on their time cards they were at work when they weren't. That's absolutely terrible. You need to never do that. But it is really nice to work in an environment where there's some flexibility over your time. You need to be at your meetings and get your work done. Another nice thing about the labs is that they're large enough to find other opportunities if yours is canceled. They tend to work from a full-time equivalent. How many heads do we have? And they worry about budgets from one year to the next, making sure they cover that. So there's opportunities. If something happens that your program is canceled, there's probably another spot. And the other thing is usually the benefits are pretty good, and you may or may not be thinking about that yet, but good health insurance and retirement all is important as you make your way through your career and get ready to get to the other end and enjoy it. On a con side, the government process of changing budget priorities and program cancellations can create churn, and that problem is worse now than it has ever been. I have friends who are or have been program managers at NASA, and it seems like they're always making a new set of PowerPoint slides, replanning their program because of that churn. That doesn't seem to be really appealing to me, but it is what happens. The other thing is the pay is potentially less than in other places, especially initially. I turned down a salary of 80% higher to go to NASA because I really wanted to be there. The people want to be there. It's a great place to work. And the other government labs are very similar to that. My next one is, I call it nonprofits. I'm not sure what else to call these, but I've got my list down there. The National Research Center, the Aeronautics and Space Engineering Board. We did studies for NASA, pulled together committees of experts, and held meetings to come up with recommendations on what NASA should do. University Space Research Association, or USRA. I managed the NASA USRA University's Advanced Design Program, which was targeted at capstone design courses. KU was a participant. And finally, the National Institute for Aviation Research, which is a hybrid because it's part of Wichita State University, but the way it operated with the NIAR piece was more like a nonprofit. I was the Associate Director of Research and Development there. The pros of that, if you're a more experienced engineer, there are likely to be challenging assignments, good assignments for program and project managers. The pay tends to be really good. I got a 30% raise going from going to USRA. The offices tend to be nicer. At the Aeronautics and Space Engineering Board, I had an office in a building up on the hill in Georgetown, and I had a window that looked out on the airplanes arriving at Washington National Airport. And the benefits tend to be good. They take care of the people who work there. Couple of cons. One is that most of these are subject to funding availability. While I was at USRA, the NASA contract ran out. It was not renewed. There I was without a job. They weren't big enough to have another opportunity. I did get to spend a year looking around and helping out with some other things, but sometimes they run out. That's a downside. The next one is academia. I spent about 4 years at Embry-Riddle Aeronautical University. I was an associate professor in aerospace engineering and had release time, 3/4 release time, to be director of student success programs, which when I got there, we had a Department of Education Title IX grant, and it included both the Daytona Beach and Prescott campuses. I loved the academic environment, the flexibility that you have. You have to meet your classes, you have to meet your office hours, you have to get your work done. But if you need to take off and run to the post office or run to the store or do something, you can do that as long as you're meeting your other requirements. One of the good things, there's some repeatability because you teach the same classes. Once you've done all the work to put a class together, it's not as difficult the next time or times. Might have, as I did, multiple sections of the same class in a semester, so the prep time is not as much. There's an opportunity for administrative management as well as technical as you go along. That was a special request of mine when I went to Embry-Riddle. I wasn't involved in any research projects, and I wanted a place to use my management skills and came up with that through student success. You have an opportunity to work with students and help them achieve their goals. And to me, that's very revitalizing and very fun. It's also possible if you were there as a researcher to build a national or international reputation in a research area. And benefits tend to be pretty good. There's some downsides. One thing is, as I found, it's a lot of work to teach a new class, to put together the syllabus and develop all your notes and figure out how am I going to meet all these ABET requirements as I'm putting together this class. As a research faculty, there's pressure to attract research funding. Right now, that's a big challenge for KU and many universities. We need to increase the amount of research funding. That pressure winds up on the faculty members. And there's also pressure to get tenure. And getting tenure is usually a 6 to 7 year process. Once you've got it, the pressure's off, but you're still, by then you've built a reputation and you need to keep going to keep performing. If you don't get tenure, it usually means going somewhere else. And so that's a kind of a traumatic event that can help, that's unique to the academic world. The salary that you get depends on the institution. For engineering professors, it's generally pretty good. I'm aware, since I'm on the advisory board, that at KU, it's been pretty bad the last few years in terms of pay raises and keeping up with the cost of living. So again, it depends on the institution and the situation, but academia can be a very happy place to be. And then finally, industry. I had to work harder to come up with the pros for this. I went to industry last. I was at Boeing as manager of aerial refueling systems for the International Tanker Transport Aircraft, which later became the KC-46A, although it's really a whole different airplane because of changed requirements. I was at Cessna. While I was there, it became Textron Aviation as a senior engineer specialist in research and advanced technology, and then as a black belt and master black belt. And I wound up my career at Spirit Aerosystems as the lead engineer for portfolio management in research and technology. The thing about industry that's good, there's good pay, there's usually really good benefits, and sometimes challenging projects. I say that because one of the criticisms of industry by new hires is they go in expecting, I'm going to be working for Boeing, I'm going to design an airplane. No, I'm really going to design a flap bracket on part of an airplane, a very small part, or I'm going to do a stress analysis on a very small part. Sometimes getting going, it's tough to get the really challenging projects initially. But if you do your work and you volunteer for more and you keep going, those will come. The cons that I found, there's a real lack of flexibility. There are a lot of meetings. I used to say Spirit was the Spirit meeting company. We specialized in that. And you are expected to be at those meetings. It's been different in the last year with people being remote and using Zoom. Before that, it was you need to pretty much be in the office at your meetings. There can be very long hours and pressure to meet schedules. And I know, especially at Boeing, I met a lot of people that wound up divorced and in uncomfortable family situations because they had put their time in at their job and to the detriment of their family. You have to look at corporate culture, the exact opposite at Cessna. Even though there were times when there was great schedule pressure, it was also, there was consideration for family needs. And I was fortunate to be there when both my parents went through their end of life situations, and I was able to be flexible and be where I needed to be in both cases. Another one of the cons of industry, in my opinion, because I am a night person and I like to show up in the afternoon, very early meetings, very common to start working at 7 in the morning. I spent 6 weeks as a Boeing Welliver Fellow while I was at Embry-Riddle, and in order to have use of the virtual reality conference room to review what had been designed the day before and converted to virtual reality that day, we had meetings that started at 6 in the morning, and that is painful. And then another con is the possibility of layoff. Industry doesn't want to lay people off, but they do wind up having to do that sometimes. I went through Cessna going into half size 10 years ago, 12 years ago. I managed to be one of the lucky ones that stayed. Spirit, I understand, has decreased by about 40% since before the 737 MAX and COVID problems. So those are places that you can work. Now this question of where didn't I work? I never was a consultant, haven't been a consultant yet. The nice thing is you can make a lot more money, but you have to provide your own benefits. You absolutely must be a self-starter because people are not going to come to you and say, Vicky, would you please solve this problem for me? You have to be out marketing yourself. You potentially have more freedom, maybe a lot more freedom, but you all have also the freedom if you don't work, you don't eat. So you really are responsible for yourself. Related to that is a contractor. A lot of companies hire contractors to get key skills and to fill in workforces. So it's a lot like working in industry. You may be in a company office. You make a lot more money, which makes the engineers jealous, but they don't realize that you're having to provide your own benefits, which you find out that's another 50 to 100% of your salary to do that, what your company does for you. Contractors are good in that you have the opportunity to work on really interesting projects. However, you also are the first out the door if there's a downturn. And that's why companies hire contractors. We can lay off the contractors. It's not taking a whack at our own people. Another thing that people don't really think about, but does happen, is getting a degree in law, which would take 2 years after you get your bachelor's degree. And you could be a lawyer in anything, but one of the common things for engineers is to become patent attorneys because you have the technical background, and maybe even become patent examiners to help try to reduce the backload at the patent offices. But those are the possibilities. So I'll wrap this up quickly and then we'll get to your questions, which I see have not been pouring in, but when I get done running my mouth, hopefully they will. Just want to conclude with this thought that you have to work at it to make it a career and not just a job. And it's really good to have goals in mind, but you also need to be flexible enough to take advantage of opportunities when they make sense, even if they're not on your direct path. Always use other people's money to the maximum extent you can to pay for education. And concentrate on the most technical first before you lose those skills. You need to keep lifelong learning in mind as a way to be successful. It's a key. And finally, participating in technical societies and professional societies is a great way to network and learn and make another contribution to the profession, which is what you're about when you want to have a career and not just a job. You will find that a BS in engineering will take you wherever you want to go if you're willing to work at it. So my advice is the world is yours. Take advantage. Thank you. And I'll take questions now.
All right. Thank you. Thank you, Vicky. That was great. Got some questions here. I will say that you anticipated several of
Many of
them, and
them.
I'm crossing them off. Okay, but here we go. Here's some questions. Okay, early on, you mentioned you originally had the goal of retiring early and working with students. You ended up changing your goal and doing something else. How important is it to set goals, and when is it okay to change goals?
That's a really good question. It's important to have a goal so that you have a reason every day to get up and pursue what you need to do in order to meet that goal. You need that motivation to keep going. In my case, I made that jump from USRA to academia to Embry-Riddle because the contract ran out at USRA. And the question was, what am I going to do now? It turned out, well, I want to be in academia. So that seems okay, but I want to go there and be able to use my management and administrative skills. And that worked out. But when I got there and I really got into what it meant to be a professor, I figured out my goal was good. I'm enjoying the students. I like that, but I'm not enjoying the politics of the university. So my goal was right. My timing was wrong. And now I've retired. And right now I'm not interested in doing anything. I'm having too much fun. So, I've thrown that goal out again. But if I get hungry And if university budgets get better, then I may be back saying, I'd really like an opportunity to come teach a class or play with the students in some aspect.
Okay. You sort of addressed this. What did the MBA, the Masters of Business Administration, teach you that was different from a master's in engineering?
The MBA gives you this overall business integration. You take classes in accounting and in operations and organizational. I'm sitting here thinking, what were the classes I took? They were good. In the case of my management of technology, there were classes in learning about things like S-curves, how technology becomes obsolete and new things come in. And in engineering classes, you study the how to make something happen. You don't necessarily study the how does it fit in the world and when does it make sense to do this versus doing something else. And where I really appreciated it was while I was at Spirit, in my role as lead engineer of portfolio management, our CEO brought in a consultant to look at how we did research and how it paid off. And we wound up, worked with him. I was the Spirit side of the partnership that developed Spirit's 7 distinctive capabilities. And we did that by meeting with the research people within Spirit and talking about not just what is your project doing for us today, but what should we be doing to be a tier 1 manufacturer of aerospace structures with the goal of not just building what you tell us to, but being able to go to the table and say, here's what we have to offer that will improve your product. You're not going to learn those nuances necessarily in a master's degree. You'll pick it up in experience as you go along. But an MBA is a good way to really get an appreciation fairly quickly for how what you do and what you can do makes sense to help you figure out, well, which route should I go? What would be the biggest payoff to the company? Because companies are in business to make money. And the more you can help them do that, the more successful you will be.
Okay, you took a co-op and when you were an undergraduate and kind of bounced back and forth between working outside the university and continuing your education. Would you recommend a student stretch out their undergraduate schedule so they can do internships?
Absolutely. Absolutely. And with internships where you could do that during the summer, you may not really stretch out your time that much. With co-op, it took me 5 years to get a 4-year degree, but I ended with 3 years of civil service seniority. So when I went back to work full time, I was eligible for more vacation every year. And I had that experience because NASA counted my time at school also as being on the payroll, even though they didn't pay. Anything you can do to get experience that's relevant to what you want to do while you're getting the education is ideal. It will make the education mean more to you, and it will help you get more out of it that will make you more effective as a new engineer. For example, I hit a point where I thought if I hadn't co-opted or had an internship, I might have decided I didn't want to be an engineer based on what I was learning at school. And I really thought, I think I might want to switch to journalism. I think that would be a lot more fun. But I went to work and found out, no, there are lots of really exciting technical problems that I can come here and work on and be around other people who are working on and hear about and learn about. I want to do this. The other thing I found was I remember taking a class in aerodynamics, and I thought the faculty member, and again, this wasn't at KU, but he was adamant, this is how you do it. And I looked at that and said, well, I've seen us do that at work a different way. I don't believe we have to do that. So I'm finding out that everybody has their own perspective, and it helped me appreciate that I had the ability to look and learn and not just take as face value what the faculty members were telling me. So yes, it's very, very worthwhile to have that experience if you can get it.
Okay. Would you have additional advice for a recent PhD graduate starting as a research engineer in a company like Boeing or GE?
Good
So,
luck.
yeah.
That one, the advice probably is the same, but the circumstances depend. I'm going to assume here that this person got their degree, worked with a faculty member, and now they're out looking for a job and going to work as a new engineer with a PhD. Boeing or GE is going to hire you for a job that requires those skills. So they're not expecting you to just be a bachelor student. They may expect it's going to take a little while to learn where the cafeteria is and who your coworkers are. But what's really important is to go to work with an attitude of, I have a skill set they hired me for. I need to look for every way I can find to put it to work, because that is how you get noticed when you're solving problems that your boss doesn't even know he has yet. That's a good thing. So, and recognize your problems are going to be bigger magnitude because you have a bigger toolbox and a bigger skill set, but you know that, and that's why they hired you, why they're going to pay you more for that experience. So go to work and have fun. That's the main thing. That's one of my other modems I didn't put in here, but who wants to work with a grumpy butt? I learned
Mhm.
that from one of my bosses at Embry-Riddle. It's like, as long as you're legal and ethical and it's non-fattening, it's okay to have fun and be pleasant.
So, since you've worked for government and industry, for a student coming out today, how would they, and you mentioned the pros and cons of each, how should a student choose? Like what the right path is for them? Do you have any guidance on how to weight those things? What's more important?
Well, it depends on what you think your goals are. If you want to move along the technical path and for sure get increased degrees like master's and PhD, then looking at the government side is a really good way, because the educational benefits will be better and easier to acquire. If you're not sure, or you think, no, I really want to get out and make some money, and I'm interested in just getting to work, then industry is fine. It's a good place. And the bottom line in the end is, you go where you can get the best opportunity or an opportunity. Sometimes the job market is tight, and it's much better to be working for industry than to be sitting at home not doing anything because you couldn't get the job at NASA that you wanted. So you have to be kind of practical about it, but you do need to think about where it is you want to go. Another piece of advice that I didn't put down here or talk about is, if you're going to do that technical path, do it right away. Don't wait. When I was balancing school and work, and then I went to work full time and started school part time, the HR department at NASA tried to tell my supervisor, no, she should wait till next spring to start her master's, because she'll have to do her GS 7 to 9 project this fall, and that'll take time. And my supervisor, Harry, said, nope, absolutely not. We're not going to let her lose her study skills or figure out that she has money. We want her to just keep going so that we don't lose an opportunity, because you do wind up, and I haven't done a good job of showing this in me because I'm a bad example, but people do wind up finding boyfriends or girlfriends and getting married and having families. And as you do that, it gets more complicated, but it's still doable. And it's just better if you've done the education piece before you get too carried away with the other things, because it's nice to have that. Once you've got your MS degree or your PhD, they won't take it away if you don't use it every day.
Okay. You mentioned corporate culture, different corporate cultures, Boeing, Cessna. How do you gain an understanding of a corporate culture before you take a job there?
You do as much research as you can, you do as much networking as you can, you ask questions when When you interview with people, those are good kinds of questions to ask. What is your culture like here? How family friendly is the company? How often are you stressed by deadlines that are unrealistic? How much overtime do people work? Another thing that you can do, and it may be harder as a new hire, but I found it useful in my later jobs, I asked to actually meet with employees during the interview process. I would like to have an opportunity to spend an hour with 2 or 3 employees to talk to them about what they're doing and what the company is like and how much they enjoy working there, so I can get a sense of, will this be a kind of place that I will fit in and would enjoy? Or is it going to be, oh my gosh, we have to be here working every Saturday and there's no flexibility, there's no opportunity to take off to go see your kid's soccer game? Like, oh, I may be a little reluctant to involve myself in that. So anything you can do to find clues ahead of time before you've made that commitment, because it's sad when you get there and find out it's not what you thought. And in my case, I've had a lot of jobs, and every time that job was never what I thought. In all but one case, it was better than what I thought. So that was good, but you don't know till you go. And so anything you can do to gain intelligence ahead of time. Now LinkedIn is a wonderful resource. Look for some people that work at that company and see if they'll make friends with you, and you can ask them, do you like working there? What's it like? You might
Very
also
good.
build yourself a network to help you get in the door that way.
All right, 2 more. Did you have any international experience, and what is the importance of international experience?
I had one brief international experience while I was at Spirit. I managed to survive without international experience. I'm not recommending that as the way to go. I know that there are a lot of opportunities now for undergraduates with study abroad programs. I think those are excellent. Even if it slows you down a little bit on being able to graduate, you may find that that experience is beneficial. It is definitely an international world. I say I didn't have, I traveled once internationally for work. And then actually I went to a couple of conferences, so I'm going to add to that more. But at Cessna, as a black belt, I led a project that was focused on fixing the IT support system at our center in Bangalore, India. And after that project, I said, I specialize in solving problems with people I've never met at places I've never been. I was able to solve that problem by using groups of people at the various sites. And today it would be Zoom. Back then it was whatever our system was, but online meetings to solve the problems. Being able to understand the culture was very important. Being able to hear what people were saying and translate that into what does that mean they're going to do or they're willing to do was important. So being aware and versatile in the international world, yes, is a very valuable skill these days. I wish I had had more experience with that.
Okay, last question.
Okay.
How does professional society membership benefit your career beyond just saying you're a member?
It lets you say you're a member. As I mentioned in my presentation, it helps you with networking and meeting other people. It also helps within your company. A lot of times the companies invest in professional societies to help achieve their goals. And when they see you as an active member, it may help you. For example, at Spirit, John Pilla was the VP of Engineering and Technology and Information Technology. And he was very involved in AIAA. And I wound up having a whole relationship with him away from my job as a research and technology portfolio manager, working on AIAA things. So it gives you a chance to build deeper relationships with people, sometimes higher up in your company. And it also gives you a chance to make a contribution to the community. So opportunities to go give papers. Industry goes back and forth about can they afford that and do they want to invest in that. But companies that are serious about growing and developing new wind up with their employees involved in committees on those professional societies, in going to conferences, because not only do you go tell what you're doing, but you go learn what others are doing and can bring back and maybe find a way to implement that within your company a lot more efficiently than if you had just looked and dreamed up the idea and tried to do it yourself.
Okay, very good. Thank you very much. I want to thank Dr. Johnson for coming and sharing her thoughts with us and her experiences. It's been great. We really appreciate what you've shared with us today. Thank you everyone for coming, for participation. We encourage you to share the lecture series with your friends, and we look forward to seeing you all in the future. So with that, thank you all for coming again, and have a great night.
Thank you, and bye-bye.